The Story of Everything, Chapter 8, The First 6 Minutes, The Big Bang Nucleosynthesis Epoch. Blinding white light with a slight tint of blue, searing heat, and surprisingly no sound, encased in plasma so thick I couldn't move, but that very quickly melted away into a thin fog. That's about all I got out of that deal, of experiencing the Big Bang in real time. At my very first moment of consciousness, I couldn't see anything but light, but I could sense that the universe was already much bigger than the solar system. By the time I counted 1001, I knew the universe was already 9 light years wide. By 1003, I realized that the first 6 epochs of history were long gone. At 10 seconds, we were back where we left off and entering the Big Bang Nucleosynthesis epoch. As I was saying, Sophia continued, the universe is almost done. It just needs to bake for a few minutes. Welcome to the era of Big Bang Nucleosynthesis, where we see what it's like to live inside a hydrogen bomb explosion for 6 minutes. Thank you, sister. It's good to be here. For the first time, we just stood there silent, which was a nice change of pace. But I was surprised Sophia wasn't talking, since we were now in real time, eating up vast chunks of time compared to the previous epochs. I finally spoke up. So, what's going on? Well, we have a couple minutes of spare time before anything really important happens. In the meantime, is there something on your mind? Yes. How is God going to save the neutrons? I'm getting worried. Is he going to work some kind of miracle to make them not decay? She replied, That's not how God works, my child, and it's not how nature works. And presuming that God regularly interferes with natural processes is not how science works. Science is the discovery of natural causes, not supernatural causes. And the creation of the universe and its laws in the beginning was God's divine intervention. We don't need to give God stuff to do. He already saved the neutrons when he made the seed of the universe at t equals 0 seconds that unfolds every step of the way through every Planck time and all the billions of years according to his purpose. God, in his infinite wisdom, gave nature everything she needs to fulfill her mission. She doesn't need any more help. If she did need his help, his creation would be deficient and not at all impressive. True, I said. She continued, What's more impressive? A Ferrari in optimal condition racing down a road doing what Enzo Ferrari designed it to do? Or a Ford Focus hobbling along with its hood open, and Henry Ford is in there, desperately cranking the engine so it will go? I laughed. Ferrari, but isn't it, what do you call it, deism or something, to say God just let the universe do its thing? She replied, Is it deism to say that your digestive system just does its thing without God miraculously intervening to make you digest your food? I guess not, I said. Deism, she said, is the false assumption that God is disinterested in and distant from his creation just because it can take care of itself. That's as dumb as saying that Enzo Ferrari takes no delight in seeing his machine operate, or that none of his brilliant mind is in the machine. In fact, God is never distant, because his wisdom, power, and divinity are written within the very fabric and laws of space-time and all it contains. The entire history of the universe and its working, as a wisely arranged whole, together with all its parts, is a single creative act. Therefore, God's action permeates the whole of nature as the one who wrote its story, gave a start to its existence, and maintains its existence so that it can unfold as written. These actions of God are primary. You must discern between primary causes and secondary causes. The primary cause is God Himself, who acts outside of time to give the entire universe, past and present, its order and existence. What the universe does on its own, with causes and effects naturally flowing from the laws of physics that God already built into it, those are the secondary causes. Secondary in the sense that such causes presuppose their own existence, nature, and order supplied by God in order to act, things that they cannot give themselves. The natural sciences do not study God or angels or ultimate causes. That's for philosophy and theology to do. Instead, the natural sciences study secondary causes, specifically natural causes. The moment you start invoking God as the explanation for a scientific gap in your knowledge is the moment you're no longer doing science. And no, this does not hurt God's feelings. God made it so. To study nature as nature in and of itself gives glory to God as the infinite intellect who shines through the majestic ordering power and awesome intelligibility and mystery of nature. You will soon see how everything needed for you to exist in the 21st century has already been here from the very beginning, especially since inflation. So don't worry, you won't start partially vanishing like a time traveler in a DeLorean. You'll get your neutrons. Okay, I said, I think I get it. Good. Okay, we're almost 2 minutes into the Big Bang nucleosynthesis epoch, and a major event is about to happen. Time to tell you what's been going on. I interrupted. Well, I have noticed that I can easily move around, and I can sort of make out your figure in this fog. I haven't seen you in a while. And what does that tell you? She asked. That the universe has become a lot less dense in the last 3 minutes. That's correct. And that means that the universe needs to cook up something more than hydrogen quick, because normally densities like those at the core of the sun are needed to smash the baryons that make up atomic nuclei together to make heavier elements. This smashing together of protons and neutrons to make different kinds of atoms is called nucleosynthesis. Nucleosynthesis is the building up of heavier atoms from lighter nuclei, the lightest of all being hydrogen, which is just a single proton. It does this through fusion to make heavier atoms like oxygen and carbon, which are necessary for life. Fusion, or synthesis, simply means fusing nuclei together, which releases an enormous amount of light energy, which is why fusion bombs like hydrogen bombs shine so brightly when detonated. Now, this initial burst of nucleosynthesis in the first minutes of the universe is called Big Bang nucleosynthesis, or primordial nucleosynthesis. Got it. But why is this happening if the density is too low? Because the temperature is still extremely high, just under 1 billion degrees, which is still 1,000 times hotter than the core of the sun. In fact, for the first 2 minutes of the universe's history, the temperature was too high. At first, when protons and neutrons tried to fuse together to form something called deuterium, the photons were so energetic that these deuterium nuclei were instantly destroyed. This destruction of atomic nuclei by photons is called photodisintegration. What's deuterium? I asked. Deuterium is what's called an isotope of hydrogen. The number of protons is what makes an atom hydrogen or carbon or gold or silver. But each element might have one or two extra neutrons, or might be missing one or two extra neutrons. The number of neutrons determines which isotope of hydrogen, carbon, gold, or silver you have. Instead of being just a single proton, deuterium is one proton and one neutron. It's called heavy hydrogen because with two baryons, it's about twice as heavy. There's a third type of hydrogen called tritium. It's even heavier because it has two neutrons. So an isotope is an atomic nucleus plus or minus an extra neutron or two. You can also smash two protons together directly to make heavier elements, but that process typically takes over 1 billion years, and we obviously don't have that kind of time. So deuterium is our only hope right now. Why? I asked. I mean, why can't the universe just bash dozens of baryons together to make all different kinds of atoms? Nucleosynthesis doesn't work that way, she said. You have to build elements up element by element, starting with the lightest, hydrogen, which is a single proton, and working your way up to helium, which typically has 2 protons and 2 neutrons, to lithium, which typically has 3 protons and 3 neutrons, to beryllium, which typically has 4 protons and 4 neutrons, and so on. Okay, I said. She continued, now, even though the total energy of the thermal bath we're in has fallen low enough for a proton and a neutron to fuse together to stably form deuterium, you must remember that there are more than 1 billion photons for every deuterium nucleus. So these nuclei still don't stand a chance against this brutal hail of photons. Photodisintegration is still going on. This inability of the universe to move on to constructing heavier nuclei until deuterium can literally get its act together is called the deuterium bottleneck. And this bottleneck is forcing us into a very tight corner before the density and temperature get so low that neutrons can no longer be fused to protons and thus survive to build elements other than hydrogen. Wait, why does a neutron become stable just by being bonded to a proton? That is an advanced level question not suitable for our discussion just yet, but I'll give you part of the answer. Once a neutron is welded to a proton, it's no longer just a neutron. It's more than that. It's deuterium or helium or lithium and so on. That's not a trivial difference. It becomes part of a greater structure, a structure that is more than the sum of its parts, that has properties that protons and neutrons by themselves don't have. In a sense, you could say that no neutrons have survived after all. They have all been taken up into a new substance. Some of their original properties, like the decay we've been talking about, are suspended because they're now part of something else, a new system. That makes sense, I said. Okay, it's 3 minutes and 20 seconds in, and the photon bath is becoming diffuse enough now that the first deuterium nuclei are sticking together without being blown apart by photons. Back at 3 seconds into the history of the universe, we had 85 protons for every 15 neutrons. Because of the deuterium bottleneck and the fact that neutrons were constantly decaying into protons in the first 3 minutes, there are now about 88 protons for every 12 neutrons. Oh, great, I said. Don't worry, she said. As with everything else, it's going to turn out that that's just the right amount of neutrons. We're coming up on 4 minutes now, and hydrogen is being burned, so to speak, into deuterium at a tremendous rate. And now the most important step is starting to happen at the same time. It's great that deuterium is finally forming, but deuterium is still hydrogen, and we don't want a hydrogen universe forever. We need at least the next element up, helium, which consists of 2 protons and 1 or more neutrons, usually 2, to balance out the protons. This is called helium-4, the 4 indicating 4 baryons, 2 protons, 2 neutrons. And that's the usual form of helium. So we need the deuterium nuclei to fuse together with other deuterium nuclei, and that's what's happening now. This is, in fact, how our own sun shines and how hydrogen bombs shine. 2 deuterium nuclei are fused together to form helium, a process that liberates a huge amount of energy. Sophia and I stood there and just enjoyed the thermal bath mayhem for a moment. We're about 5 minutes in, she continued, and the production of helium is proceeding at an absolutely ferocious rate, vastly outpacing what any star could pull off in 1 billion years. When does... I sounded like a chipmunk. I cleared my throat. When does... I giggled like a chipmunk. Ah, helium. Got it. Nice one, Sophia. When does Big Bang nucleosynthesis end? It mostly ends now, about 6 minutes in, although some minor activity continued for another 15 minutes. The temperature is now 300 million Kelvin, but the density is less than air now, too low for nuclei to find and smash into each other at a sufficient rate. How big is the... Can you make the chipmunk thing stop? I get the lesson. Sophia laughed. How big is the universe now? It's about 200 light years in diameter, a speck of dust on a vinyl record if the vinyl record were the Milky Way. And what's next? I asked. What's next is the final stage of the big ball of fire we call the hot Big Bang. Good, I said. I'm looking forward to some cooler weather.